All right, let's get started again. What I'm going to be talking about is the firmware, system firmware on the Arm servers. And also, as we are aware that we're looking at the OSF efforts, right? So I want to describe what we have done so far in the last decade and seek a way to work with the OCP OSF project to move forward to cover the future usages. So before getting to the what I call the system-based boot requirements, as many of you might know, in the case of ARM processors, there's also this entity called trusted firmware, right? So for the A-class processors, we have the trusted firmware for A-class, so TFA. And trusted firmware is now an open source project already. It is hosted by Lenaro, and if you go trustedfirmware.org, you can take a look at the effort there. We have many of the silicon providers working with us on that. So hopefully that effort would address the lower level firmware for the processors. And that's kind of, speaking of the UEFI language, that's kind of equivalent to the PEI module. And at the end of the TFA, you have a module where you can load payloads, right? So today, that payload is going to launch the Dixie modules and such, and then everything goes on from there. But it doesn't have to be Dixie, so that's kind of the work that we will be working on. So the background is that the Open System Firmware project in OCP, as you're aware, is an open source firmware project led by us, right, everybody, and it's intended to be deployed into the cloud environment. And in ARM, we're trying to target this market as well. So we created the Arm ServerReady compliance program based on industry standards that allow partners to develop Arm servers and deploy with confidence. One of the issues that we run into in Arm development is that before, everything is very much depend upon the vendors, right? So there could be any kind of hardware designs, any kind of firmware modules, any kind of interfaces to the operating system. So there are a lot of diversity, but it's very difficult to manage within the kind of the infrastructure server ecosystem. So we have spent over almost 10 years now to come up to a standard effort to make sure that the users can install and boot operating systems on the ARM servers with ease. And so with the new OSF efforts that we have here, ARM is seeking to collaborate with OSF to charter the next page as well. So why do we need a standard-based approach that we have done over the last decade? ARM architecture supports a very diverse variety of devices, right? Anywhere from IoT embedded environment all the way to now the infrastructure server environment. So diversity is very good, but uncontrolled diversity is a problem for us, particularly for the server space, where we have the need to address multiple different environment, different OS environment, different deployment method, and we need to have the installation process to just work, like what you experience on any other server devices today. So also what we have learned over the last years is also that the belief that we can just ask the operating systems to be modified to suit the hardware is not really a viable option for us. In the embedded space, you can just create any kind of hardware and expect that kind of adaptation. But in the server space, you can't really tell the big OS vendors to change their code just because you design your hardware differently. One example we had was some of the the devices that the features that are in the PCI spec that is actually allowed. There's an ECN that everybody agreed to, but the operating systems just don't support that feature. So expecting the OSs are going to change for you is not necessarily a viable option. So we have to look at what the OSs are supporting and make sure the hardware is designed to accommodate. So we do have, in the system firmware space, we do have this SBBR document, the server-based boot requirement, which basically uses a lot of industry standards, but also uses, of course, the Arm standards. And then we bridge the two together with some of the bindings in the industry standards like ACPI or UEFI. And so, like I mentioned, we have PSCI, SMC, SMCCC that are Arm standards and trusted firmware, as I mentioned. And then we develop ACPI bindings for the fixed function hardware and the management mode, which is addressing the bridge between the system firmware and the trusted firmware, right? So this Arm MM is actually very closely related to the SMM mode that is on the x86 side, right? It's kind of using the similar kind of firmware interfaces, but the operation mode is actually quite different. So we do have that specification that has been going through a few revisions already. And then we also talk about the SM BIOS, the TCG, TPM handling, of course PCI support. So why do we do the SBBR? In the server ecosystem, the integration model is mostly horizontal. We don't necessarily have the environment where a single vendor owns the whole stack, right? So system manufacturers and OS vendors may be separate. So horizontal integration requires standard firmware interfaces. And so SBBR provides that guidance for the BIOS, SoC, and OEM, ODM vendors. What's in the SBBR are basically guidances for the required interfaces for UEFI, CPI, and SM BIOS, as well as some of the ARM-related specifications, like I just mentioned previously. And in addition to the specifications, we also created the Arm ServerReady Program. It's a certification program which is very much like the Windows Logo program on x86. In the ARM systems, ARM is running that certification program. It's a set of tests based on a number of environments like the UEFI SCT and the LoveOS, the FWTS open source project coming from Ubuntu. So we also develop additional test cases for the compliances of these specifications. And in addition to the firmware side, of course, as I mentioned, the hardware needs to be designed to have some minimum standard support. So we also have a server-based system architecture, which provides the minimum hardware requirements based on certainly the ARM architecture, the ARM CPU architecture, SMMU, interrupt controller, some of the RAS, MPEM support. But of course, the SoC is also about connecting to the outside world. So we are having guidances on PCI specification usage, which has a lot of issues. Over the last decade, we have been trying to standardize on a lot of the PCI implementations. Of course, TPM, right? And then, now we also have, some of the accelerator cache coherence protocols for CXL, C6, and then the inter-chassis fabric, that is Gen Z. We haven't defined the guidances for those three technologies yet, but those are the things that we will be working on. And in terms of the system and firmware development, We participate in important open source projects, Linux kernel, EDK2, trusted firmware A class, OpenBMC. We also, of course, work with the OS vendors that are not open source. So we would really like to participate in the OSF effort as well. And the compliance tools I talked about help to scale out and address the experience that we want to have for the customers. So we work with silicon providers, OEMs, ODMs, BIOS vendors, OS vendors, cloud vendors, everybody together to make sure that the experience is good. And here's what I mentioned as the compliance tool, and it's publicly available. It's open source, and like I mentioned, we leveraged from many pieces. We contributed to the test suites, either pre-boot or runtime. And we check on the system firmware requirements as well as the hardware requirements. So, and we also, in this ServerReady program, we also work with the community to support the community, to debug, to test. And when the system passes the tests, then we issue a certification as well. So currently, these specifications are defined in what we call the Arm Server Advisory Committee. It's a community that's very easy to join. We basically establish an NDA between Arm and the partners. And like I said, it was officially formed in 2011, so it's almost a decade now. We have over 40 companies in the community working with us. So this is not a set of specifications that Arm unilaterally define. We work with the community to define what we want to have. There's a mailing list and issue tracker for the community to work on the changes to the specifications. And then we publish these specifications and test suites. So what I'm thinking of is to raise more, these specifications and tests are already public, but to raise more of the awareness of the OCP community, we are also thinking about just contributing these specifications to the OCP as well for people to look at and comment and give us give us advices as well. So. What is this? Why? So the call to action is we would like to see the collaboration between ARM and the OSF community. We want to support the OSF work streams. So today, like I mentioned, we have been working with the EDK2 project, but those are the Tiano Core EDK2 project. We would want to work with both the Open EDK2 project and the Linux boot projects. And we also would like the community, the OSF community, to provide inputs to future versions of the SBBR, which is the firmware specification. And of course, not only the specification, right, but also the open source implementation, whether it's EDK2 or Linux boot, and also the trusted firmware piece as well. So here are a few of the URL links for the specifications themselves. If you're interested in the test suite, these are on the GitHub. The ARM trusted firmware is, like I mentioned, also available online as an open source project. And we worked with EDK2 before, so those are the links that we have. So I guess questions.
Okay. I have a question.
Yeah.
I think one of the goals we have is actually to eliminate runtime firmware on our servers. So
Runtime firmware, okay.
we are in the process of removing SMM,
Mhm.
and we don't intend to use the runtime services at all from UEFI. So I get the impression that, and further in the long term, I think we'd really like to see core boot on there. And one thing we always saw with ARM is that really actually a desirable property in ARM is we could think about core boot. And again, core boot and Linux boot, the model is the firmware gets you going and gets out of the picture completely. No callbacks of any kind.
Mhm.
So it seems to me that this picture here is not actually compatible with certainly what we would like to do on the server side. And the question is, can you accommodate a model that doesn't include UEFI and SMM in this model, or is this an absolute requirement in this model now?
Well, so this document today is what we have done so far, right?
Yeah.
So in this model, so far, in SBBR, we do have the requirements of UEFI, ACPI, and SMBIOS, right? In terms of the runtime services, I think majority of the runtime support is through ACPI, right? There are certainly a few UEFI runtime services like time reset or timer supports, runtime. The time of day support, and of course the variable services where the secure boot is dependent upon, right? And also the boot orders.
So we wouldn't be using any of that.
Right. So in the Linux boot situation, that's true, right? So and also I think we talk about the firmware update. So Capsule service is also a runtime service, right? Right. So I think what we need to do in this collaboration with OSF, right? So when you have this OSF pass for Linux boot, then perhaps what we need to do is to look at this UEFI session and see whether any of those services are needed or not, right? So we need to work on that. And also trusted firmware, there is this environment that's, the secure world environment, which is not exactly the same as SMM, but it has some of the characteristics, right?
And my understanding is in 64-bit world, it's not optional to remove that. I mean, you can't remove that, right? It won't work correctly without it, or is that true? Or
Right, we require EL3, so with that we also have the secure world. But I think the situation is also that we haven't made any requirements yet on any of the features that are depending on that trusted world in runtime. So that trusted world, if you have the trusted OSs and all that in that environment, usually it's for the secure payment for your mobile phone, right? And so we don't have that support. And I think if you talk to Lyndon from Microsoft, he is kind of on the same page as you, that he's not wanting to see a lot of those services in the server, at least the hyperscaler environment, right? So we don't have that requirement of services that are needed in that environment. But of course, if you put these devices into Edge or any other segments, maybe people would think about some services like, firmware TPM or something like that. Maybe people want to have that kind of services.
Sure.
Right. And also, in the case of UEFI, I think the secure variables are also supported through some of the trusted firmware, trusted world environment as well. But if your Linux boot is not dependent on that, then it's also another area to look at.
It's a security thing, but we really don't want,
there may be other ways to handle that, right?
Your way of doing it with the trusted firmware, I know, is a lot more secure than SMM.
Yes, yeah.
All that said, things like SMM just are not something we want.
Right, yeah. Fortunately, we don't have SMM on our systems, but we do have the trusted firmware, so we still have to take a serious look at, what should be put in there for the hyperscalers, what should not be, right? So I think, so that's why I think, the collaboration, making the environment visible to this community is useful, and you can give us the feedback, and then we can, in the future version, this specification is not set in stone, right? It has to be changing. We're changing every year, actually. So yeah.
So there is room for.
Of course, yeah. Yeah.
If I'm not mistaken, Thunder X1 has core boot support.
Yeah.
I think so.
Here's the expert one right here. David, you know all about it, I think.
Yeah, I'm asking since I'm working for Marvel and Thunder X2 project. We are working on Firmware.
Oh.
On the spot, yeah. And I just wonder, actually, if there are some embedded devices which are running core boot as example of implementation. Do you know something like this?
Yeah, it's probably, we should catch up after.
Yeah.
Okay.
It's pretty funny. There are a lot of them, and frequently we don't find out about them until they're end of life, right? My favorite is the iRobot pack bug. Ran the predecessor to Core Boot may still be running it for a while.
Okay, the second question about test use. You were talking about Ubuntu. There's a Loop OS, right?
Yeah.
Do we have support on the Windows? Are there any Windows tools to verify SBSI compliance?
Yeah, so that tool that we talked about, it's called FWTS, right? So it's from Canonical, and it's an open source project. We just basically leverage the effort to test some of the UEFI runtime services, ACPI, tables and methods, right? So that is basically OS neutral, right? I mean, it certainly to do it, yeah. Certainly, to be able to run a test, you have to kind of run the Love OS, but it's an OS neutral testing basically. But also Windows, on the ARM side, we have a WinPE publicly available now. So we use that as well in the tests. In addition to the tools, we also try to ask people to run the WinPE for us as well to take a look at what issues they have.
Oh, never mind. I just wrote the code. No, you do it. I apologize for.
No problem.
He has to hook his up to the display.
Yeah. Do it. I think I'm done on the display side, so just to work on it. Any other questions?
Well, I thought that was terrific. Thank you.
Yeah. Thank you.